We're going to start with this one, okay? So we have two triangles. We're starting with this one. Step one. One of the things that I think gets missed here is that trig is about a specific angle in the triangle. And it only involves right triangles. So clearly we have a right triangle here. So start by choosing your angle of focus. Now, that has to be one of the angles that's not the right angle. It doesn't matter which angle you choose, but if you're given an angle, that's probably a good one to choose. So we'll choose the 25 degrees as our angle of focus. Next, label your sides. The sides need labels, and you know what the labels are. You know that they are opposite, adjacent, and hypotenuse. So we're going to label our sides. And I'm assuming nothing about your knowledge base. Starting at our angle, the one that is across from the angle is the opposite side. So label it so. Now there are two sides next to the angle. So you have to choose which one is the adjacent side. So instead, make sure you label the hypotenuse correctly first. It's the longest side, the one across from the right angle. That leaves the adjacent side here. So label our sides. Any questions about that? Next, step 3. Now, so far, you really haven't had to make any decisions, and you're not making a decision here, but I will remind you that you do know something. Right? I've yet to meet the class where everybody didn't know what this word meant, because it's not a word. Right? It is the 3 trig functions. So here's what I want you to do. I want you to write out a template that looks like this. Template. You're going to be given information. Your job is to figure out how to use what you've been given. Now, this template, this is your set of instructions so far. I'm leaving it like this because it's your instructions. But when you're actually putting this into practice, you won't write this. When you're putting it into practice, if you have the angle, put the angle in there. And if you have a side, put the side in there. This is what the template looks like. But in practice, what you're actually going to have is this thing filled out. Now, I do have an angle, so I would have probably written this as sine, cosine, and tangent of that angle, 25. I've also been given one of the sides. I was given the opposite side, so I'm going to put that in. So this is my used template, right? It contains all the things that I do have. So now that I have a complete template, I have to make a choice. Now, choices are hard, and I hate it when a set of instructions has a choice, but we will have to make a choice here. And there are 2 possibilities. Either you were given an angle, or you were given 2 sides. So that decides what happens next. So this side is going to be given an angle. And this is given 2 sides. Okay, so this is a branch, and I'm going to follow the given an angle side. That okay? Now, since I was given an angle, you don't have to do this, but I'm going to write it all fresh again because I have it off the screen. All right, back to where I was. On this side, because you were given an angle, you can immediately execute the sine, cosine, and tangent. Because of that, you can figure out what the side ratios are. Sine, cosine, and tangent are ratios. They compare one side to another on a triangle. They've just been named. So the ratio that compares the opposite side to the hypotenuse is called sine. I don't know where the names came from and don't care. There's three sides, there's three ratios. Got it? So we need to figure out what the three ratios are. This is where the calculator comes in. And this is the only time the calculator really matters, and this is the only part where it matters that your calculator's in degrees. Because your calculator is looking up the angle and telling you the ratio. It's like a little table inside the calculator. So if you want your answer in degrees, you use degrees. If you want your answer in radians, you use radians. Does that make sense? This is the only time that that's actually part of the calculator. So I'm going to hit sine 25, and it tells me that my ratio is 0.4226. And the cosine of 25 is 0.9063. And the tangent of 25 is 0.4663. I computed all three ratios because I had the angle. All good so far? Now, somebody asked, well, do I have to write out 4? Write out whatever you want. But you want this to be as close to as accurate as possible. A bunch of decimal places helps. All right, now, once you reach that and you've computed all of the ratios, you should be able to solve for your unknown sides. So that's step 5. Solve for your unknowns. I see a way to solve for the hypotenuse here and the adjacent side here. Do you guys see that? So that's what you do next. And I know there's still a few of you who don't do the math correctly because I looked at your quizzes yesterday. So please do your algebra correctly. So the first one I'm going to have is going to take 5 and divide by 0.4226. So my hypotenuse is 11.83. And my adjacent side, 5 divided by 0.4663. So my adjacent side is 10.72. We're basically done now, right? We found our two sides. However, this is what infuriates me more than anything else. People getting these wrong, because you can check your work. You're right there. Does it take much time to check your work? If you don't know what I mean, look, there was a ratio that went unused. It's the two things you just solved for. You should see if 10.72 divided by 11.83 equals 0.9063. So that's what I'm going to do. 10.72 divided by 11.83. I get 0.9064. That's really close. I think I did it right. You can check your work. That's why getting these wrong really is insulting, because you can check. You can make sure. If you made an algebra mistake, it'd show up right there. If you made an arithmetic mistake, it would show up right there. Now, that's pretty straightforward. I do know that you could have come up here, put in your hypotenuse and adjacent side. You could have also used, oh no. And what we're going to do is we're going to take this triangle. We're going to do this one now. We're going to use the same procedure, but we're going to reach that fork in the road. You might realize that I chose two triangles purposely so I could do both sides of this, right? So I'm going to start by recognizing that for us to work on this together, it would be best if we all had the same answer to number 1. So let's choose the same angle of focus. How about we choose this one as our angle of focus? And I'm going to label it with the letter theta. So have you guys familiar with theta? Mm-hmm. So theta is a Greek letter, and it is very, very much used for angle measures. Definitely in physics, but usually across the board in sciences, theta and phi are both used for angle measures quite frequently. So because you guys are smart, learned people, but when you learned letters, it was probably many years ago, but when you learned letters, you had one of these. So whenever I introduce a new character, I always want to make sure you understand what it's supposed to look like. Because eventually I have to read your writing, or somebody else has to read your writing, and if your characters don't match what's expected, you could have a problem. And it's not just about being messy, it's about being accurate. So the theta that we tend to use for our angle measures is the lowercase version of the Greek letter theta. And it does stretch out and use the entire height, just like a K would use the entire height for a lowercase k. It's similar to that. So the idea here is that it's kind of drawn like a big O with a little bit of flair. Like that the silly hair they used to have a couple years ago. They kept pushing it out of their eyes. That's what we got here. When I write it fast. So it's usually written like this. That's what mine will look like. It's the Greek letter theta. So when I refer to theta, that's what I'm referring to, okay? Typed, it looks a little different. If it's not italicized, typed, it'll be straight up like that. But most of the time, when Greek letters are represented in both your problems and in the books, they italicize them. So they all kind of have that lean to them, okay? We all okay to move on? So theta is very common. I will use it all the time. It usually always means an angle measure. All right, so I am going to clear all this out, get my template all the way empty, and here we go. I'm going to label the sides. Opposite side. Let's see, adjacent side, hypotenuse. I'm going to deal with my sine, cosine, and tangent. This time I don't have the angle, so I'm just going to leave it blank. I could write theta there, but I'm just going to leave it blank. Is that okay with you guys? All right, opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. Bless you. Okay, so are you all with me? All right, now clearly you evaluate this and you realize, oh, I don't have the angle, but I do have what appears to be two sides, one of the ratios. So I'm going to follow the pathway here to what I do if I've been given two sides. Okay, so if you've been given two sides, calculate the ratio. Get the number. The number here is 15 divided by 25. And I get 0.6 even. Okay? What I need from this is simple. I've computed the ratio. Now we're going to use an inverse trig function. Okay? Now, depending on your calculator will depend on how you do this next part. You guys have the TIs, sine, cosine, and tangent. Above it is sine to the -1, cosine to the -1, tangent to the -1. That stands for inverse sine, inverse tangent, inverse cosine. It's going to do the reverse. It's going to take your ratio and give you back the angle. Does that make sense? So we happen to have the tangent ratio. So I'm going to, right now in my calculator, I'm going to hit second tangent, and then I'm going to type in my 0.6 and hit enter, and it's going to tell me the angle that goes with it. Looks like 30.96. So that's the angle that goes with that ratio. In fact, it's the angle that goes with all of these. All right, because that's the angle of the triangle. 31 would have probably been fine, but I'm just going to do this. So now, compute the other ratios. I'm just going to compute the other ratios. So I'm going to take cosine of 30.96. Find out that my ratio is 0.8575. And now I'm going to do the sine of 30.96. I find that ratio is 0.5144. So I've computed the other ratios. Once I've done that, there should be a pathway for me to solve for my missing sides. Now you'll notice I didn't actually have to compute both ratios. Do you guys see that? Because one of them would have been fine. But if I have both ratios, I can check my work. So I'm going to, step 5, compute missing side. So that's going to be hypotenuse equals 15 divided by 0.5144. I get 29.158. Is that what you guys got? Hope so. But I don't have to trust you. I can check, right? Because I can check my work yet again. All I have to do is say, take 25 divided by 29.158 and see if it equals 0.8575. So that's what I'm going to do. I'm going to take 25 divided by 29.158, and I get 0.8574. Pretty close. So I checked my work. It works out. That's the hypotenuse. Now, for us, getting the angle was the hard part. You could have gotten a hypotenuse from Pythagorean theorem. Most of you were able to do that already. It was getting the angle that was new. Okay.